our mission is really to save lives and livelihoods on a global scale. And what we came out of, our company was really born from, we have 3 different co-founders, and one of our co-founders was actually born and raised in Kashmir, India. And when he was in Kashmir, India, he experienced one of the floods in 2014, where him and his family were actually marooned for about 7 days. And in that disaster, he was already a seismic engineer. And what he realized in that scenario was, hey, we have all this data out there, we have all these tools, but why is it that in Kashmir, India, that he had to be literally on the roof of his house for 7 days? And then he actually applied to Stanford to do a PhD and met the rest of the co-founders, and then in their research, they realized that the problem that he had in Kashmir, India was actually a global problem. So what that really brought us to is the vision of, in order to save lives and livelihoods everywhere, we've developed a platform that's really based on artificial intelligence and machine learning. And what we're looking to do within our platform is we're started out with response. And we started out, our platform today is, we look at it from a multi-hazard platform, but we also look at it, today we have seismic, and we are currently working on modules by the end of the year that will include flooding, that will include fire, and our long-term goal is to include with climate change as well. So we started with response. What we're able to do is 15 minutes after a disaster, or really any event. You could even take the earthquake yesterday that happened in San Francisco during the Giants game. That was a 3-point-something earthquake, a small earthquake. But our platform was actually tested. Within 15 minutes, we'll be able to give a live damage map showing in real time where the damage would be. Obviously, for a 3-point-something earthquake, there's no real damage. But if you could imagine, there's been a lot of press lately around the Hayward scenario, the Hayward fault line that runs pretty much through Oakland. And it's obviously a very urban area. There's been numerous studies based on that fault. And what we would be able to do is to provide that live response. And then, of course, the platform rolls out to providing real simulations. And the simulations, what happens is when you run those, you can actually identify a specific community. You can actually, if you're more advanced as far as understanding faults and understanding geology, you can run a specific type of earthquake as well. And this is going to extend out again throughout our whole platform. But our goal really here is to provide a total resiliency. And what that also includes is long-term mitigation. So what we're able to do is we give these resilient scores that go down to the very block level within a community. And you can understand from an ROI perspective of what different capabilities, what different mitigation strategies, and the ROI that will give. So a few here, you could see our founding team. Again, they all met at Stanford. And what we're really combining is this hardcore science and the artificial intelligence, so of the discipline, of the computer science, and then the area experts, the emergency managers. You could see there, you could read through. We do have our chief emergency officers, Craig Fugate, used to head up FEMA, General David Petraeus, Rick Chirino, and Judith Roden, who used to lead the Rockefeller Foundation, and she launched the 100 Resilient Cities. So that's a little bit of where we're coming from as a company. I know we don't have that much time here today, so probably in the next 5 minutes or so, I'll go into a little bit about what actually our platform looks like. But before that, it's good to understand, we kind of throw out this term artificial intelligence and machine learning. Now, it's great to understand the methodology that you do things, but it's really the output that matters. And what we are creating for an output is a digital fingerprint pretty much we're starting with the United States and we're extending out really globally. But we have, for each building within the United States today, we have about 150 different variables that go into that digital fingerprint. So what we're using that for is across the whole platform that we talked about, we're using that fingerprint to make predictions, to make recommendations to help, to help all of our users, right? So some of the areas that we're looking at are the built environment data, demographic data, natural environment data. But really the secret sauce is taking all of this together and applying a machine learning concept and having these computers, if you will, to learn and to make observations of the data. I'm not a computer scientist myself, but someone made this analogy to what machine learning does, which is essentially, if you would, I don't play chess. I don't know who plays chess in the room here, but if I don't know the rules of chess, you can actually have the machine to observe chess, and then over a period of time, the machine will actually understand the rules of chess, right? So you don't have to teach it, you don't have to train it, it learns based on observation, right? So this is something that it can be extremely powerful as it's being used, as the platform is used more and more. And part of that is what we call collective intelligence. So what we're able to do is, this is taking not just the machine model, but this is taking all of your intelligence from the field. So if you would go and our prediction model would say that it was a moderately damaged building, but in real life, if it was actually should be a red tag, then that would actually propagate throughout the system, and the system would automatically make adjustments to the whole, not just to that building, but to every damage map. So if there was an Eichler house that was built in 1952 with the exact same soil, with all of those same variables, then it will propagate throughout there. But it's not even just limited to the map itself. It's limited to what we call the second order or third order dependencies of that building or of that structure. So that's a few things to look at. Let's jump in. We have a few minutes to look at what the output within the platform itself. So what we're looking at is, imagine 15 minutes after an event, this would actually, you would be looking at this map. And at this, what we're looking at is, we're looking at the different structures and we're looking at the damage between residential and commercial buildings. So there's a lot of adjustments that we can go through. You can change the filters. You can look at what we call building block damage index 1, 2, 3, etc. And you can also take it even greater to look at a hyper-local level. So you can basically look at this by any kind of demographic data. And this is all the data that we have within the platform today, but we can also bring in what you might have on your GIS layers to bring this into our system. So again, this is something that is very highly customized. Included in that, you can take a look at any critical infrastructure. You could actually take a look at this and you could say, within that sphere, you could say, let's look at all the hospitals, let's look at all the schools. And you can see this and you can see what would be operational. And then you can also draw correlations between if the hospital's out, but there's no water supply, then the hospital, it's not operational, right? So you can do this from a second order dependency and a third order dependency. And within that area, it will tell you who's impacted, the demographic data, etc. A few different metrics as well, as we say resilience metrics. I wanted to give you a couple examples. We used this at an event recently with the city of San Francisco. So we can ask a question to the platform and say, what about food access? What will happen within an earthquake? So the darker the shade, this will actually show within the map of where there's no food access. You can do this again with schools. For those of you that have children, well, it's not just the ability for your children to go to school, it's that, well, if they can't go to school, then who's going to watch them? It's pretty hard if there's a disaster or a major event to be able to get childcare. So you can look at this and say, for the city of San Francisco, you can say those would be the areas that would be greatly impacted, right? And then you can dive deeper. Our mapping is all down to the block level, and this is just an example. Some of the agencies that we have working today, we have City of San Francisco, we have City of Los Angeles, Cupertino, and we have Woodside Fire Department, Portola Valley, and a few others. So our company is about 2 years old, and we're growing fast. There's about 40 of us, mainly all on the technical development side. So please come by the booth, and I can talk to you more about it. But thank you very much.